Wanted to make a video today about the Cherri Programming Language that I wrote. Cherri is a iOS shortcuts programming language that is 100% written in Go. It's 100% open source, and it's for writing shortcuts with text, is how a lot of people say it. And so what I'm going to be talking about today is mainly the source for the Cherri compiler. I'm going to do a code tour, but I'm also just going to talk about Cherri in general and just kind of its syntax and how it works. If you don't know what shortcuts are, excuse me, shortcuts are little automations that you can do on your iPhone and iPad and Mac that just kind of help you do things a little bit faster. But they also have scripting language functionality. So they can kind of be a scripting language in their own right. So it's basically just like it's a scripting language, but like done in blocks. And that comes with its own set of conveniences, but it also comes with its own set of inconveniences. So doing this is quite tedious. And so being able to write these in a programming language is kind of convenient. And um, writing a programming language for a shortcut is not super difficult if you've written a parser that, turns something into something else. So talk is cheap, right? Let's pull this up and just kind of show you what I mean. So I'm going to make a hello world file here, and we'll just write the hello world for Cherri, which is just alert, hello Cherri, and we'll write that. And I have the Cherri compiler installed on my system here. And we'll do hello world.cherri. And that compiled pretty fast because it's pretty short. And here we have hello world.shortcut, and you can see that the preview pane, the quick look, and even if I open it up here in shortcuts, will accept it as a valid shortcut. People might not know this, but since iOS 15 and macOS Monterey, shortcuts now need to be signed. And you can only sign them on macOS. So, unfortunately, this compiler is macOS only. You can obviously build the source, and there is an option to skip signing, but you're not going to produce a shortcut that can actually be that will actually be of use if you don't have a Mac, unfortunately. I am hoping to do something about this in the future with a cross-platform web editor. So, like any platform where you can get to a web browser, you can make a shortcut and then put it on a Mac or an iPhone or an iPad or whatever. Um, so, and yeah, and then that editor will just communicate with the Mac, and it will sign it, and everything will be hunky-dory. That's what I'm hoping to do. I'm not sure if that will actually happen, but hopefully, maybe by the time somebody's watching this, that is already a reality. Um, so this directly compiles to a valid runnable shortcut. If have ever tried to run a shortcut that you've generated yourself or generated with some older shortcuts programming language, you'll know that this only happens if it's been signed, if it's valid. So you can see here that it doesn't complain at all, and we got a direct runnable shortcut. So obviously, uh, this is very helpful. Uh, so um, we declare variables like in other scripting languages with one character and then the name of the variable. and then we set it with an equal sign, and then depending on like kind of what we put here, so like, you know, if it starts with a double quote, it's a string. If we put a number here, it's a number. We can even have expressions. Excuse me. And then we can also have arrays, which cannot, cannot contain each other. So unfortunately, you could not have an array in an array. The way that this works is that in shortcuts, you can create an array by creating a variable, declaring a variable, and then adding to that variable. And so that's basically what we do here. But you cannot currently do that inside of itself. Not that I'm aware. So, uh, well, it's still pretty cool, and it allows you to have more types of values than, say, like a list action would. So a list action, just like in shortcuts, it has to be all strings. You know, like that. But an array, you know, I can have a string, I can have a dictionary, I can have a number, I can have all sorts of things, you know. So yeah, so let's move this hello cherry just to show the next part. Excuse me. Is that we can reference variables just like that. We don't need to have an @ sign or anything like that. And you'll also notice that I did a alert without specifying the title or whether or not the alert should have a cancel button. This is because Cherri actions have default values. They don't really have default values if, you know, if we're talking about how the language works here. Basically, if you don't supply a parameter for a action, shortcuts will just kind of assume what the default value that it has programmed into itself. So obviously there are arguments that we need to have to proceed or to really do anything useful. So obviously alert, we have to have the first argument, but we don't need to have a file, a title to this alert, or uh, tell it whether or not we want a cancel button. We could just have it assume that. So that's one thing that's great about Cherri. It So I was talking about how it's a scripting language, and it's a scripting language in the sense that it kind of takes the scripting language philosophy. So like we don't have to, you know, use a var keyword. We were able to just, you know, have a symbol and then an identifier. You know, there are a lot of conveniences that we just don't have to think about, and that's kind of the whole ethos that we're going for here is make things just about as easy as possible to where like not so much that you don't know what the final shortcut's going to look like. I still think that's very important. But you know, if there's things where it's like, well, we could just keep track of something for you rather than you having to specify, you know, everything. As long as it's not really going to mess with, you know, you being able to know what the final thing is going to look like, um, uh, then that's the thing that we should do. Okay, so whoops, sorry about that. So let's get out of here and you know, just kind of look at some examples. I think this is going to be probably like the best way to show people without having to try and remember everything and show everything. So that's what I'm going to do. So conditionals work very similarly to how they would work in a lot of other languages. We do support booleans, which are essentially just abstractions of one or zeros. One like a number block with a one or zero value. But you can declare them as a true or false, and then compare them, use them as, you know, if an action has an argument that's a boolean, you can use a boolean variable. Uh, to do that. So there's a whole abstraction there for Booleans. Just while we're talking about conditional logic, um, for has any value or does not have any value, you basically just have to either give the variable or give the variable with a exclamation point prepended on it. This is common in a lot of other languages, and so I didn't want to make it too complicated. Anyways, so yeah, so and then we have the equality operator that we can use. We have the non-equality operator, so just not, this would be is, greater than, less than, greater than or equal to, less than or equal to. And then there's ones that we have a bit more syntax with. We're missing two here. One is contains and does not contain. So we just put an exclamation point in front of it. And begins with and ends with are literal. They're just in camel case. And this is how we do between. So int var between 5, 6. We can nest conditionals inside of each other. We can do this as many times as we want. And obviously we have else as well for the otherwise. But as you can see with each of these will all evaluate and compile properly. We can just have an else, an if statement, and we don't have to include the else. It's just required that you do this, you do your condition, and then you just need to close your braces. Excuse me. Okay, so let's move on to the next one. Definitions. So any kind of meta stuff in Cherri is always prepended with a £. You see that kind of a common thing, just to keep it all consistent. So definitions allow us to basically, like I said, define kind of meta things about the shortcut. So you can see here with we can define the icon here. So we can do a color and a glyph, and I can demo this here for you with our hello world shortcut. So define color yellow, define. You can do these in any order, by the way. I just wanted to mention since I'm doing it kind of the same in as the demo there. And then I'll compile this, and then we'll take a look at it. And you can see it has a yellow color and a smiley face to say hello. So this is kind of how we define those things, and it works pretty well. Yeah, it allows us to also define though inputs and outputs, where we can call the shortcut from, so like sleep mode, menu bar, if it can get content from on screen. Like this is kind of where we can get stuff from, where we can be accessed from. Yeah, and then we have a way of handling no input. So this could be get clipboard, or it could be stop with, and then we can give a response. So that's pretty neat. And then this one may or may not still exist when you're watching this, because this one is not supported in newer versions of iOS, I think. I think that this is just here just in case it, I don't know. I wish it worked, because this I guess used to be a way that you could, with spaces and everything, you could specify what the name of your shortcut could be. So for me that would have been really cool, because you could have whatever name for your file, and then you could actually give it a proper name. But that doesn't work, unfortunately. So, and then we have dictionaries. So dictionaries, just like I said before, just need to be valid JSON objects. Yeah, and then they will be made into a full-on dictionary. And we have all the actions for getting values, getting keys, getting a value for a key in a dictionary. Um, yeah. This is maybe like the least sort of ironed out part of the language, but it does work. It just doesn't work very well. Hopefully, by the time you see this, this will hopefully be in a better spot. So this is how we do getting something as something. So like in the case of these globals here, for device, we can get the OS and the system version just by putting some brackets. And we can do the same thing inline. For type coercion, we put a dot and then the content item type, which I'll get into in a second. It's a way of defining. It's a way that the shortcuts format defines a type. Um, yeah, I'll get into that in a second. And then we can inline it by putting it in parentheses, since we need to have a stopping point for it. So yeah, let me get into what content item types are. So this is the documentation site, by the way. You can reach this from the repository on GitHub. It's just a small GitHub pages site that you can also contribute to if you find something that's wrong. So content item types are these content item types that the format uses to define a data type. So we kind of shorten these into singular names, so like text, number, URL, media, image, folder, things like that. And so these are just kind of generally used in various places by the shortcuts format to define different types. They're mainly used for inputs and outputs and like type coercion. So that's what those are. I'll probably stay here. Yeah, so that's that. I guess that would, yeah, good thing. Next, that's what I wanted to talk about. So globals. So globals are all implemented. We have the shortcut input, the current date, the clipboard, the device, ask, and you can even put these inline just like you can other variables, but they are case sensitive. So these are always capitalized, or in the case of this one, they're always, capital case. Yeah, you can only use the ask in certain cases, just that's how Shortcuts prefers it too, but otherwise you can pretty much use these wherever you want and do the same kind of things that you would do with them in Shortcuts. They're just globally defined. They're just variables, but they're of a certain type of variable. So that's that. Oh yeah, so this is like kind of the official Hello World to kind of demonstrate all the syntax, although you don't need to have these two arguments, as I said, as in other actions, but yeah. Cherri does have support for includes. So this works in kind of a frustrating way right now, because if you include other files, it's hard to know exactly where the problem is happening, because you're essentially just telling us to paste another file in here right now. But I'm hoping in the future, and maybe by the time that you're watching this, that we will kind of have some concept of what file we're including this from. Maybe we'll handle includes a little bit differently to accommodate for that. Okay, so yeah, we can include files inside in included files, like even though that it's if you get something wrong, includes work pretty well. You can include files inside of files and create a whole include chain. You just can't include the same file more than once in an include chain, obviously. For now, anyway. Now that I think about it, that might be kind of silly, but I don't know. Okay, so this is a vCard menu. This is choose from menu, and this is a choose from list. These are the different types of menus that you can make in Cherri. Obviously, the simplest is the menu. We don't have any syntax where you have to specify each menu item. I've seen other languages where the shortcuts languages where you need to specify these items before you actually make them, but this is not the case in Cherri because this is one of those like scripting language ethos kind of things where we keep track of this stuff for you. It's like you don't have to specify this stuff directly. We're not, it's not going to affect the speed of your shortcut or anything like that. You make these items, and then as you're making them, we kind of group these things together and just keep track of what you want to do. That was very important to me because I know in other languages you have to, specify them. If you compile this, or just like, if you've used shortcuts before, you know that you generally have to specify, items here, and then that's what kind of creates these blocks. But yeah, we don't have to do that. It was very important to me that you're able to do that, and you are. It's kind of similar to a switch statement and syntax, kind of thinking about it like that. Yeah, and then we have choose from list. This is just, you make a list, or I think you could also like just make an array, which again would just be like that, and so on. And it will just present the user to pick an item, and then you'll get the item back. So, yeah, and then this is a vcard menu example. So if you don't know what a vcard is, it's essentially like it's a virtual card format. It's kind of like a contact format, like a an address book application kind of contact. Um, so we have a custom built-in action in Cherri called make vcard. Vcards are essentially contact cards, and you can group them together and put them in a choose from list action, as you can see here, to essentially show the user a menu that will have a title, a subtitle, and an icon, and that's what these are. So the vcard format is fairly simple, but it's not very easy to remember. So you know, this is kind of coming from my own experience making shortcuts. Is that I would always have to cross reference one of my other shortcuts for vcards and like how to do them. It would be really nice if in the future we could make some sort of syntax for just making a vcard, and you don't have to worry about the way that they come together and all that. But for now, we just have something that essentially just makes the format for you, um, which essentially just makes a text block, um, like you would. So yeah, so this would go in the spot of the uh, name. So go in the spot of the company or organization, and this will go in the photo. This one is particularly interesting because at compile time, basically what we'll do with this path is we'll get the image of this path and base64 encode it and insert it into the vcard in the photo section. So it makes it a lot more convenient for you to make these vcard actions, because you're not having to put in the base64 version of the image and keep that in there. Depending on the size of the image, it could be a really long base64 string. The only inconvenient thing about this is that this needs to be a string literal, because this is something that we do at compile time. I guess this is kind of like a macro or something, like a meta thing. And yeah, so this has to be here. This has to be an image that we can access at compile time. This has to be a path. You could have a variable. That's fine. If you want to have like this is the path for this and put it here, that's fine. We'll be able to go to the end of that variable chain and evaluate it. But this needs to be available at compile time. That's the only disadvantage to it. But it's like, considering like most of the time you would just be making a menu where you have like a set sort of thing here. So you're making a menu with like icons. It's like you can just have a folder somewhere in your project where you keep these icons that you want to use, and you just put a path to them, and we'll just figure it out at compile time. So that's the make vcard action, and it's pretty cool, I think. So yeah, and then we have numbers. I was talking about you can do expressions. So we basically just look after the number to see if if there's more characters to tokenize. We just see if you have a operator, a mathematical operator, and then we just put that into a calculate expression option action. Cause see how there's a calculate expression action and shortcuts. Yeah, and then we have these sort of number actions. We have more number actions than this. This is just an example. And then, yeah, menu kind of showed this briefly, but we do have repeat syntax. We're also a scripting language in the way that we kind of keep like minimal syntax. So you'll notice there's no, and this is the same with if statements, there's no parentheses at all. So yeah, so we can either just repeat something, a certain number of times and have like an if nested in here, and then if we have a list of items, so if we do like a list or like an array, we can do a for each. So we also support getting a list of a list of the user shortcuts, opening a shortcut, running a shortcut, and passing it some input. And then this last boolean is just whether or not you're running yourself, which we also support since we have those. So I'm thinking about splitting that into another action, like run self or something. But yeah, that's kind of another thing that I wanted to talk about is we'll kind of get into this a little bit more. Yeah, with this next example, we split actions to minimize complexity. So we'll have actions like correct spelling. I'm sorry, I know the syntax highlighting here is inconsistent. Um, I define my own syntax highlighting in Golang, so I have to like add all of these, and I just haven't. Anyways, so we'll have these ones like correct spelling, split text, combined text. That's fine. But when you get into stuff like this, where there's a replace text and you need to specify whether or not it's like regular expression or like case sensitive, that might not even really apply to what you're doing here, right? So that's what we do is we have like replace text, we have case insensitive replace text with I replace text, and then we have reg replace text, which is a regular expression replace text, and then we have ireg replace text, which is a case insensitive regular expression replace text. You got that? So yeah, so it's like for actions like this where it's just split text, combined text, it's pretty simple. It's just what do you want it to be separated by and give us the thing that you want to do it with. But when it comes to like changing case, it's kind of more convenient if you just have like one action that you can use and you don't have to remember, it's like, oh, it's change case, and then the specific thing that they want is uppercase, or like, you know, I don't like having like an enumerable for like a string value basically. So I like to split them into actions if I can, especially when you have a limited number of actions, and it's like, oh well, good luck with that. Here's an argument where you just need to fill in the right thing. Hope you remember what it is. It's a lot easier if you just have actions that will do that for you. So instead of having to have the compiler yell at you that you didn't put in the right value for an argument or something. Um, but yeah, these are our various text actions. These aren't all of them. These are just some of them. And then finally we have variables. So these are those action variables I was telling you about. Um, these are booleans. This is an array. Oh, come on. This is a multi-line string, even though the syntax doesn't show up quite right. This will work. And this is an inline variable. Text with an inline variable. These are numbers, dictionary, expression, list. You can also have an empty variable. Now, when you compile this, this is, just going to be, you know, set variable with an empty value. But if you want to declare something, like at the top of your file, just for organizational purposes, you can do that, and you don't need to, like give it an empty value or whatever. You just declare it, and then you don't do anything. And then we have syntax for adding to a variable, which is just plus equals and then the value that you want to add to the variable name here. So it would be same syntax, just with a plus. Um, okay, and then with some of these you can already see like we have single line comments and then we have multi-line comments. So this one I can indent like that, and I could go on for a bit. Um, I think we just didn't feel the need to have like an example for that. So, but yeah, let me see if there's anything I'm missing here. Yeah, imports. So, a lot of people ask about like non-standard actions and the like. So we do have support for that, and I'll probably go into that. But yeah, it's the same sort of like meta syntax, and then just if we have a library in there that's the non-standard actions. The non-standard actions don't have to be imported. They're just always available, and or the standard actions, excuse me, are always available. They don't need to be imported, but extra libraries do, so that we don't have to allocate memory, keeping those actions, allocating those actions into memory so that you can use them. Um, yeah. Um, yeah, so that's how you would do that. We have a list of glyphs. We also have a list of colors, and for inputs and outputs, we have, like I showed earlier, we have a list of the content item types. All of the stuff is defined and documented, so if you want to know more about the Cherri language and how it works, if there's any more questions that you have, like I said, just find Cherri on GitHub, and then there's a link to this site here, which has pretty good documentation, I'd say. And if there's something missing, then you can improve it. You can contribute to it. Um, so so yeah, so something that I may or may not have already talked about is that these shortcuts are macOS only. So if you want to do cross-platform development, you're going to need to build for your platform. I do put out releases, but they are macOS only, and that is because shortcuts can only be signed on macOS since iOS 15 and macOS Monterey, um, because Apple is very paranoid about malicious shortcuts and them getting generated and all that stuff. So, because you can do some kind of scary things with shortcuts. So, um, but yeah, so that's why it says here macOS only, and that's kind of the way to get access to it, is to either build it or download the latest release, which will just have releases here for Darwin, which is the macOS kernel, for ARM64. So this will be your M1 or your Apple Silicon, and of course old Intel Macs, x86 64. Okay, so so yeah, I wanted to talk a bit more about just this is kind of the part where I'm gonna probably just get into the compiler and how these things work. Oh, excuse me. Um, So if we just run the compiler on its own, we've got some options here. I'll just kind of get into like things that the compiler can do. So we just take a file in. Uh, that's pretty much all that we can do with the compiler, and we parse it, and then we output a .shortcut file, as you saw earlier. But there are some options for how you would like it to do this. So first we have share. This is the signing mode. This is something that we pass directly to. This is the signer that I was talking about. Oh, excuse me. That exists on Mac OS. We parse the file. We generate a property list or a .plist file, um, or plist. I don't know. And then we pass the unsigned shortcut that we've made, um, which is essentially just a property list in the shortcut format, uh, except it has a .shortcut at the end. That's basically what it is. And we pass it this file, and we tell it to sign it, and we'll pass this output to it, but we'll mainly just pass the signing mode, the output, and the actual inputs of the file. Um, so that's what that is about. The default is contacts. Um, so this is like who you want to be able to share it with. The default is contacts, because if whenever you sign it for contacts, it signs quite easily and quite quickly. But if you sign it for anyone, the shortcut has to be uploaded to iCloud. There's like a thing, like see how whenever you export a shortcut and you change the sharing to anyone, I think there's like an explanation there. Like it takes a little bit longer to sign it because they need to like upload it to iCloud and verify it, or sign it differently or something like that, for sharing with anyone. And I think it's mainly just they want to keep the way that you sign these shortcuts kind of closed off so that no one can uh, uh, do this too freely, I guess. I guess they're trying to uh, keep the likelihood of you getting a malicious shortcut that was just generated on the spot less likely. I'm not really sure. But that's the reason that it's the default, because generally people want to share these with their contacts, but signing for anyone actually just takes longer, and I don't want that to reflect badly on compile time. Um, Even though that I know there are some people who want to share for anyone, but it's a pretty easy command line argument to su- supply. So the next one is unsigned. So unsigned is whether or not you want to sign the compiled shortcut. I put this in here for people who maybe want to develop on like Linux or something like that, or on Windows, but they just and then take it to a Mac. Uh, but yeah, that's really the only purpose of this. Or like maybe you're working on this and it's not signing, and you don't want to just be signing it over and over. Um, there are many different reasons you might want to do that, I guess. And then I think maybe the other reason is you want to just have a raw shortcut file. I don't know. Um, the next one is debug. And then, yeah, just a warning on the unsigned thing. Like it says there, if it's not signed, it won't run. It just won't be valid unless you are using macOS Monterey launched with the signing, so there's no macOS version other than Monterey that not only no macOS version that will run shortcuts other than Monterey, but that's where the signing started. So you would have to do it on like iOS 14, 13, or 12. Um, so yeah. Uh, the debug is to save generated plist and print debug messages and stack traces. So what that means is that you have assigned shortcut, but you can't really do much else with it. So right, so like if I drag this into text edit here, um, it's like I'm gonna get a uh, somewhat of a a plist here, but you can see it's like it's signed with the Apple Application Integration Certification Authority. So this is all like encrypted and kind of nonsense. So we can't see it. It starts to become kind of a binary. Hence the whole kind of encryption and signing. So what you'll want to do sometimes is you'll want to have a debug not only to print out a lot of uh, um, helpful debug messages and stack traces, but uh, to get the actual just raw plist file that we compiled so that maybe it's not signing, um, and you want to look at the plist file and see like, okay, is this invalid XML or is this invalid so far as like the shortcuts uh, file format goes, or so far as the property list format goes. Property list is a key value pair. If you put something invalid in there, it might be valid XML, but it's not going to be a valid property list, right? So that can help with debugging. Um, Also, just like I said, like you'll get a signed shortcut, but you can't actually look at the plist that we generated. So it's helpful if you can just get that saved, because you could technically, I believe, like if I'll just do this here because it's a little bit easier. If I rename this to like plist, and then I run like, I think it's like plutil hello world.plist. Yeah, I think it won't go back because it's encrypted. You can't get to it. So so yeah, so that's like mainly why we do that. It's just kind of maybe there is a way, but it's just kind of a hassle either way, and it's just kind of easier. Debug messages are to print the like the stages that it goes through is what I mean by debug messages. So it'll say when it's parsing, it'll say when it's generating a plist, it'll say when it's creating each of these files and going to sign, passing the file to the shortcut signing binary. Um, and so this can be good for debugging because it'll, if something prints out while it's signing or creating a file or parsing, then you know that the error occurred like during then, um, or that because you might have like these abstracted functions that can happen like anywhere, and that's kind of where stack traces are helpful too. So basically, what that means is that if we get a parser error, um, instead of just exiting, we will panic. So in Go, that means that we'll get a stack trace of where we panicked, and then we can trace it back to where in the parser we ended up having a problem. Because maybe we're giving this error, we would give this error for a valid reason, but in some cases that's not what we're supposed to be doing, or we're not finding what we're supposed to find when we're parsing it. So that's what that's about. Um, Let me take a drink of water here. Excuse me. Okay, so and then output basically we just pass the path to the shortcut sign. So you'll see that there's also an output flag here, and we just pass your thing, whatever you put as the value for this to that. Excuse me. So we we have these as the actual argument, and then equals, or it's like I don't know if you call this like POSIX compliant. It's like just the normal like Unix thing of like you can do like a dash dash for the full word, or you can do a single dash for the single character. So we don't have these like afterwards. We actually have you do like equals and then whatever the value is, and it's the same for output. Oh, excuse me. Same for output, or oh, so that's how that goes. Um, so yeah, so let me do that, the hello world with D. So you'll see that we print out every time that we do something, so we can kind of get a sense of like, what stages we got to before we crashed or something, or we ran into a parsing error that we weren't supposed to run into. Excuse me. Um, so what we also print out here are some helpful things. So these are the tokens that we parsed. So here we have, if we open this up in text edit, and we kind of look at these side by side, we have the actual tokens that we got out of here. So we got the message. This defines it as a string variable. This defines it as a variable. So this is message, and then hello Cherri. This defines it as a string. Yeah. And then we had action, alert, and then we have the actual alert, variable, message. So this is just kind of a representation of all the tokens that we garnered out of this file. These don't make it in as tokens. We just define things using these. So we'll just like read these and then just go, okay, so because these can only really have one value, so we don't make tokens out of them. And then these are this keeps track of variable values. So this just like has like just a global spot that we can access variable values from anywhere and check if a variable exists by its identifier. And this is just so that we have a pre-allocated space, and also like instead of just passing around all the variables. And then here we have a map of you wouldn't see it here, but if we have a menu with a prompt and a case, I don't necessarily have to put anything here, but I will just so it doesn't look weird. Then you'll see that we have this menu here. We have this grouping identifier for this menu, which you can also see here up in the menus token. And then we just have these cases, and this is what we use to keep track of the items. So we just have like a pre-allocated like space where we just put the grouping identifier, and then we just keep the items in there. And this is basically just because if you look in the shortcut that we made, we have these actual items, and then we have like a list of items. I think I explained this earlier, but like we have the syntax, and so this is just basically where we keep track of them. And so this is just like a debug for that, so that it's like, oh well, we have menus in here, we weren't properly keeping items, or something here is weird. We just want to see these places where we're keeping track of these things that we're not putting in the tokens or whatever. Yeah. So yeah, and then this happens after the plist. These are the UUIDs for variables. The shortcuts format makes heavy usage of UUIDs, or universal unique identifiers, and so we generally just do this whenever we generate a plist, unless we need to do this at parse time, so that we can kind of keep these things in relation to each other, and so that we can do nesting. Which that's generally how we do that, is we kind of keep an index of the closures, and we have a UUID at a certain index. I think we have like a map of like an index and what UUID is at that index for this kind of nesting chain. Um, and Right. But yeah, then once we get into the plist thing, variables just need to have a UUID, just generally. So we'll make one for a variable uh, that will keep it there. I think either that or it's like the action output. This is something that I also haven't brought up that maybe some people might be curious about. We have no concept of magic variables in Cherri. And the reason that we do this is that generally this doesn't really work for a programming language, in my opinion. You have two types of variables ever in a programming language. You have in JavaScript, you have like a let, and then you have a const, you know. Um, and this is just mutable and immutable. You don't really have these things called magic variables, which I found variables can also be considered magic variables. Um, and so in Cherri, that's why they're kind of considered one and the same, because I think other languages kind of stumble when they try to do this, because in my opinion and in my experience using other shortcuts programming languages, it just adds complication. That's all it does, is just, you know, you need to be able to, like we can in our language, Cherri, just apply the output of an action to a variable name and not have to worry about it. And yeah, you'll see in compiled shortcuts that we apply text to a variable, and this is kind of everywhere in the output of a Cherri file to a shortcut. But in my mind, I don't think that this is a bad thing. And maybe there's an optimization that we could do here to just use the magic variables for the output of actions, and just sort of pass them around like that. But to me, that's an optimization that can be made on our end, and doesn't really need to involve um, the person who's making the shortcut at all. Um, that just seems unnecessary to me. And then I'll show you the one other thing, which is like if I just kind of flub this. So we had an illegal character here, and we'll get this whole kind of thing here. So if I ran that without D, I just get this error. I get where it happened in the file. I get a little visualization here of what it had a problem with, which is a bit off. That's a problem I'm hoping to fix. So adding D can really help in this case, because we'll actually get a stack trace. And if you're in an IDE, this can be really helpful, because you can often click these, line numbers and go straight to them, and sort of trace it back to where exactly the parser error occurred, and then we don't have to wonder about where exactly this happened, especially with things that are more just abstract in general, that are used all over the place. It's like, okay, well, where did this occur, like, just generally? Because a legal character, that just comes from, like, a value parser, and so on. It's like, well, what were we parsing a value for? We can trace this back here. So that's what that's about. Yeah, and that will compile successfully. There we go. That's kind of the good thing, is like no answer is a good answer kind of thing. We don't have this compiled successfully or anything, because there's just no reason to. So pretty fast. Okay, so let me go into a tour of the actual compiler now. I guess keep in mind that I do not claim to be an expert in programming or the Go programming language, and this compiler is very young. But yeah, I will cease making excuses and just start in main. Okay, so basically we just start with defining some things about the file. So the path that it's at, the file name, the base name, which in my view, the base name is the name of the actual file without the extension, and the file name is the file with name with the extension, just to clear that up. Contents is where we sort of store the whole file, and then the relative path is the path that we were given, if we were given like a full path, if we were just given like a file name, so just, compile a file in the current working directory. But if not, and we were given one that's, in a folder and in another folder, that's what this would be, but without the file name. And that's essentially just mainly so that I can't remember exactly, but I think that we maybe incorporate that in the output. If you don't give us an output, I think we might compile the shortcut in the same location. I'm not sure. I know that we mainly use it for includes. So we, if you give us a relative path to a file, that file can include other files in its directory. And so we use this. So if you don't have like a dot dot in the include path, we'll just prepend this relative path of the file. And then here we just have a slice of the included files. So this is just kind of how we keep track of the files that have already been included. Like I said, this might not be necessary, but that's what that's for. And then we have just a constant of what the file extension is. This is basically just like if we ever wanted to change this in the future, because like I said, this is rather verbose. But this is also just so, like, I don't know, so that the file extension is pre-allocated and stuff. That might be kind of stupid, but I don't know. Yeah, and then finally we get to the main function. So we register the arguments, which is it just goes to an args parser that I wrote, which just, you register your arguments. We parse through the OS args, if we have more than one of them, obviously. And we'll take the values and try and correlate it with a short and a long name, and we'll print them out automatically like they should be, although this is custom. So this is just like from one of my other projects. I use this in a lot of my projects. And then we just have these arg and arg value functions. Yeah, I need to reduce the complexity of this. Thank you, Linter. What am I trying to say here? Yeah, so this one is just whether or not this argument was provided, and this one is the specific, like, if we're expecting the argument to have a value. So like with the share argument or the output argument, this would give us the actual value of the argument. Like the value that's like after the equal sign, essentially. Okay, so that's basically what that is. It's just, we're just telling the args parser these are the arguments that we expect. If you can match those up whenever we check for them, that'd be great. Because whenever we do run those like arg and arg value functions, we give it just this name, and we don't really have to worry about whether or not it's the long or the short one, or how the description gets printed out. We just provide these things, and then we're done. And then we just run this usage function, which was that thing I showed you that just prints it all out for us. If there's less or one argument. Let me just exit. I think what I'm doing here might not be POSIX compliant. I don't know. I feel like I've seen other things exit with a 1, but I don't know. We exit with a 0 because I don't want to make it seem like something bad happened. You just didn't give us a file. Yeah, and so if we get past here, that means that we actually have something to deal with. And so we take the first argument and make that the file path. And then we go to this function called check file. And so this just basically checks if it's a Cherri file and if it exists. We have this in a function because we have includes, and so we have multiple places in which we need to check if a file exists and if it's a Cherri file. So that's why that is. Yep. And then we just split and do a bunch of stuff to get the base name and the relative path and all this stuff, and then we actually read the file and load it into memory. And then before we parse the includes. So like I said, this might not be the best way to do it, but it essentially just, if it contains a £sign include, then we go, this is the first time that we split up the lines. The other time is when we have a parser error. We actually don't like just separate into lines and then separate into characters for each line. We go through the whole file character by character, so the only time that we split into lines is this, if you have includes, and for a parser error, so that we can add a specific line and be like, hey, we didn't like this, and you need to fix that. But otherwise we break it into characters, so there's no need to break it into lines. Okay, so yeah, so this just checks the file and checks if it's already been included, and then if not, we just come back. If we did find an include, then we'll put it at that position in the lines and then glue them back together, and then check if what we glued together has an include, and do that recursively until we get them all. And then here we start parsing. I will go into each of these like larger things like parsing into more detail. I just want to get with the main function. This is where we print the tokens, the variables, and the menus if we want the debug. And then we make the plist, and so this is, we take the tokens and then we generate a property list file. And then if we've been asked to, we save that file. We save that to a file. I don't know if I showed that or not. If I didn't, I know that I'm pretty sure it's in here. Yeah. So if you asked for a debug, we'll actually give you the property list file, like I said, and we can, if you're on a Mac, download Xcode. Xcode has a pretty great property list viewer. Hello. There we go. Sorry, I'm like recording the video and doing other stuff, so it's not super snappy right now, obviously. Yeah, and then we can just kind of go into each of these actions and see their properties and stuff like that. So this is gonna be really great for debugging and not having to like just look through a raw thing here, especially because we're not really able to format it. Maybe someday, but right now it's not. There's not really a reason to, because you can just put this into an XML formatter or look at it in Xcode. So, but yeah, this is like the file that we made from this one, like we would do here. Okay, and then we make an unsigned version of the shortcut. So we take the base name and just add underscore unsigned that shortcut, and then this is the file that we hand to the signing, unless we've been asked not to sign it because we're on some other platform or we just don't want to for some reason. Yeah, and then this just takes the mode and puts it into that command, and then we delete the unsigned shortcut if we were successful. And we can just leave it to this command because this command will save it wherever we set the output path to be, which, like I said, is either just the base name with the dot shortcut or it's your specific output path that you gave. Yeah. Okay, so a little bit more on the specifics. So let me see if there's like a simpler one. No, I'll go over like the general functions and main. We have like one that's just for handling errors, one that's for getting the end of a slice, one that's for checking if a string slice contains a string. And sorry, the end of a string slice specifically. And then we have one that makes a shortcuts UUID. This is specifically here because just because of the syntax, it's like it's not just UUID.new, it's also UUID.new.string. And then Shortcuts does their UUIDs in uppercase. So this just kind of does all of that for us. I don't know if it's required to do them in uppercase. Maybe it's not, and also maybe there is a. I know that UUIDs aren't super performant, so maybe if that's not required, there's a more performant version of that that is better for Go and or just better in general for performance. I'm mainly doing it in that format because I just want to try and match the shortcuts format as best we can. Just yeah, because this is obviously not the conventional way to do it, and so we just want to try and replicate it as much as possible. Okay, so those are those. So yeah, let's get into parsing. So the parser, like I said, just loads the whole file into memory, and then we just split it into characters. And then we go character by character. We have a index of which character that we're at in the character's string slice. We store the current character as a rune, which I guess if you don't know is like a 32 bit or something like that. Like it's like a UTF-8 character, so it's not. It's like a Unicode thing, so it's not like like an ASCII character or anything like that. So we can predictably store any kind of key we want in here. So it's stored as like I think it's literally like an alias of like in 32. So it's like a 32-bit number that we store the current character in, just as the number that it would be in Unicode. And so that allows us to not be storing a character as a string and take up less memory where we can save it. And then we have the line index and the line character index, and this is mainly just for error handling. So we don't really care about this in parsing. This is mainly just to keep track of what line and what line we're on and what character we are on in that line or what column we're on. Just so that we can display a nicely formatted error for it. Excuse me. Okay. So the next thing that we have here is the closure UIDs, the closure types, and the closure IDX. I think I talked about this before when I was talking about like menus and ifs and repeats and stuff like that. So that closures can be nested inside of each other, it's not really a problem because like at the end of the day, actions are just stacked on top of each other. They're just a bunch of dictionaries in an array in the property list. It's not really important. What we care about is the type of a closure, so that they relate to each other when we go to print them out, and they have the same grouping UUIDs, so that shortcuts and us, when we're printing them out, know that they're related, and we keep the closure index because the closure index goes here in the key. so that, as we go in and out of closures, we can change this closure index, and whatever it happens to be on will be, the same type and UUID um, as the other ones. So like if we're in an if, and then we do all this stuff, whenever we get to an else, even if we were nested in ifs inside of that if, we subtracted the closure index, so now we're back at that first if when we go to the else, and then now we'll be at that index and have the same UUID, because that UUID will be stored under that index. Okay. So yeah, so then we start parsing, we make variables, we make actions, we make menus. If you know Go, this is like just to make the map of where it is. Yeah, and then we do the same for closure UIDs, closure types. And then we make globals, which just means that we store them all in the map uh, for globals. And this just stores a variable value type, which I'll get into. But yeah, that just makes them available, essentially, um, so that we know what they are. Or we know which globals are available, basically. Um, so yeah, and then we split the contents into characters. We set the index to -1, and then we advance. And this is basically just so that we can end up at the first character and have the first character in chars in char because of what advance does. And what advance does is it just adds to the index. So we're at -1, and so we'd go to 0. It compares the index to the length of the characters so that we don't get an out of index error. Because if we do, we want to go back to -1, which in a lot of cases causes loops to stop. That's kind of the trigger to be like, okay, we've run out of characters, we can't do this anymore. And yeah, and then, but if not, then we'll convert the character at that index in chars, which is, all of the characters in the file like split up into a slice. We'll get that as a rune, and we'll get the as a, as a rune slice, and then we'll put that to 0, because I don't think that we can just get the rune, because I guess I don't know. Maybe somebody can figure that out. This is the best way I've found to do that. So yeah, and then this is our magic to kind of keep track of the line and character index. So obviously, if we get a line feed, that means that this would mean a new line, but yeah, that would mean that we need to increase the line index and reset the character index. Otherwise, we reset the character index for the line, not for the where we are in the file. And if not, we need to increase the line character index. So again, that's just for error handling. We also have an advanced times thing really quickly here that just lets us run this as many times as we'd like. Oh, why are we doing that like that? That's weird. That might be the thing while I'm going through here. I might make little tiny tweaks. Yeah, and then we go until we run out of characters, basically, in this main loop. We don't stay in this loop at all times, but this is the main parsing loop. We do a switch. We do a switch because if you think that an if-else chain is the same as a switch, that's just not true. Basically, switches are better if you have like a lot of conditional logic where just in different cases you need to do different things, because and a switch will jump to um, the logic for a particular case. as far as I understand it, and it's a lot more efficient than an if else chain. Um, and so, well, in most cases, like obviously in interpreted languages, whatever, but in Go's not an interpreted language; it's a compiled language, so we need those. It's a lot more optimal. Many cases I've had the Go linter suggest that I make if else chains into switches, even if I'm not going to have a main condition. So that's that. Yeah, so we skip spaces, tabs, and new lines. And then we start looking for tokens. So tokens are defined in token.go. We set up a token type, which is just a string, but we want to restrict where, like, oh, this argument can only be a token type sort of thing. And yeah, so that just kind of helps us know whenever we get a token here, we have like a type of and a type for a value. What type it is and how we should handle it. So right, so then we have a struct that defines a token, and then we have a main pre-allocated slice of tokens, and so this is where we store all of our tokens. I'm not really sure why this is still here. Seems a bit odd, unnecessary. I think I'll keep that in the back of my mind for afterwards. This was from back when I was doing it by line and keeping track of lines and columns in tokens. But I stopped doing that once I realized you can't do multi-line comments if you're going line by line. So that's that. Yeah, so then we just use that to identify stuff like variables, if else, send ifs, repeat, like stuff like this. And sometimes it's stuff like this where it's just um, it's like the values of these don't technically matter. It's like sometimes we use these to identify things. So like you might have seen like token ahead definition. And so define is the actual syntax, and that's what we're expecting to be ahead if we're going to proceed, and then look for stuff that matches the syntax of that keyword. But some of these are like don't really matter. Like end if is not like the actual syntax for end if is an ending brace. So, but we have a token for an ending brace. So some of these are just symbolic of like this is an end if token. This is where we should have an end if block, you know. But an if will actually start a conditional like block. And I guess what I mean by that is like if I get down here is these are mostly literal. So set is we're looking for an actual equal sign, add to we're looking for an actual plus and equal, and so on. So these are all actually going to be literal. Like these are the actual things that we're looking for. But up here, you see variable, but that's not exactly what we're looking for. Maybe at some point I will redo this or refactor this to where like we have like at token type equals to at something like that. Because I guess I'm starting to realize that might be inconsistent, but yeah. Oh, there's an old comment. um, so yeah, and then we have like some more tokens. So like for definitions, so name, color, glyph, inputs, outputs, from, version, no input. Possible values for no inputs. The different types. So these are partly just values that you can have for like a value type for a token. Comment is maybe a bit weird. Maybe that should be up in the keywords, but it's not really a keyword, it's more of a type. So these are like the main types that actually exist in um, the shortcuts plist format. The rest of these are kind of just like for us. So like conditional, action, variable, expression, comment, true, false, state. Those are more just for us to know how to handle the type of value. Um, but 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 these usually correlate directly to something. So booleans actually exist, arrays actually exist, dictionaries, integers, strings like actually exist in the actual format. So um, something to note here is that you will have property list data types, and these correlate to them. But they are separate, and it's because our parser and our plist generator are kind of two different things. Um, and so they like to keep track of their own data types. And so these are more the data types for the language. I feel the need to point that out, and the plist has its own thing. This is just a helper function for us to get back the literal name of a type. Um, and yeah, so basically it's just so like, string is just a quote as its value. And so what we want to get back, excuse me, is string and not a quote when we're, like printing out an error message like, hey, these types don't match. Um, then we don't want to be, uh, you know, doing, yeah, what am I saying? Yeah, like printing out like a quote and saying that that's a type when it's not. String is the type. Um, anyways, so yeah, and then these are the operators, like you said. And then we kind of have some other stuff in here. And I think it's mostly because they relate to types of tokens. So, like, these conditionals relate to these operator tokens for various different conditions. And, but yeah, these are mostly where we just kind of make stuff that we can use. So, like, a variable value as, like, the type of variable, the value, the type of the value, the actual value, which can be the name of a variable, by the way, and what we should get it as, and if we should coerce the type. We store that under a string, which is the identifier as the key, and then we have that as the value for the variables map. The menus are the same thing, except they take a slice of variable values. Conditions are a bit messy, but they're fine, I guess. Yeah, they just take usually two values and their types and a condition, but in the case of between, we have a third value for asking if value 1 is between value 2 and 3. And then, yeah, and then we have the conditions, which this is mainly so that we can set a condition because these numbers correlate to it. And so it's mainly in the parser, we can just use these tokens and not have to remember these numbers. And then this is maybe a bad name for this variable. This is where we keep track of the current grouping UUID. This might not be the place to keep this because this doesn't just apply to conditionals. That's another thing to keep in mind. Okay, so yeah, so that's what tokens are, and then we have a few functions for like handling them. So we have the most basic one is token, and this essentially just makes the current character lowercase and makes the token a string, and compares them, making the rune a string too, by the way, and then making it lowercase and comparing them. This is just so because we'd have to have this logic. on like every line of that switch statement, or every case of that switch statement. So this is just kind of a short way to do that. And then if we are in there, then we get the length of it and we proceed the length of that token and return true. So that's just like for a single token. This is generally for a single character because we can only hold one character in the current character. So we want to be comparing like single character tokens. So like, the equality operator, less than or greater than, or exclamation or something. Token ahead is for multiple character tokens. Um, and so this is essentially like, is is this token in the next set of characters. And so we'll split the tokens and um, go through them and just kind of proceed through. Like, we'll actually go there and check, and then if it's not, um, oh, we won't actually go there. Um, so yeah, so we'll go through the characters in the token. We'll skip any spaces, tabs, or line feeds, um, and then we will compare it directly if it's the first character. Um, so if it's not, we could end up returning true um, at at the end of this. Um, yeah, I kind of think it kind of makes sense to keep going. Yeah, we want to go through like all the characters of the token and compare them to the ones ahead um, before we proceed or return anything. Um, and so it just uses the next function, which I'll explain in a minute. Essentially, what it does is just it just gives you the character, um, not like add a specific index, although there is a function for that called getChar. Um, this is like, okay, if you give it like next to, what you're saying is like the next two characters. So it's very literal. And so here we're saying if the next whatever iteration we're on is not equal to this token character that we're on too uh, as a rune, then then we exit and we return false. And we kind of get through this all, and if it is true, then we will advance those characters plus one. And we do that for a reason, and that's because like usually most of the tokens have spaces between them. And so we can expect for the next token to probably be after a space. And so generally this is because we want to be able to kind of chain the token aheads. I explained this a little bit in like some of the parsing documentation, but essentially it's like this so that, or where is it? Yeah, with variable. So we can kind of do like if token ahead add to, if token ahead set, um, after token ahead variable. We can kind of just keep kind of going down and not really have to worry about like, oh, what thing are we on? What are we doing here? What's our position or anything like that? It's like, well, no, we know that we're past the token that we just asked if was ahead, and a space, so we can ask if the next token that we expect to be ahead is ahead. Anyways, so yeah, and then we can do that for multiple. Excuse me. We can do that for multiple tokens. So instead of doing something like if token ahead, and then doing or token ahead and so on and so forth, we can just do tokens ahead and just give it a innumerable amount of token types, and then it will just iterate over them and return true if one of them ends up being ahead. This was particularly useful with expressions, so that I could ask like, hey, is a plus operator ahead, or is a minus operator ahead, or is a times operator ahead, or whichever. Um, so yeah, so then the next and the previous operator functions basically just kind of pseudo seek through the tokens, excuse me, through the characters, and then just kind of give us the next one once we don't run into a space or a tab or a new line, because we're not really interested if there's a space ahead. We're not really interested if there's a tab ahead or a line feed ahead. We're interested in if the next viable character is what we think it should be. Um, and this is also just so, like, you know, you can kind of organize your syntax however you might want. This is that get chart function I was telling you about, where you can specify a specific index, and like you can see here, you'll get it back as long as you can do that. And then we have stuff for doing parser errors. I'll just go over this briefly. And these are just for, this is just an alias function to pass a error and format it as a string, and then pass it to parser error, which essentially just prints out the lines related to and the actual line that we have an issue with. And like I said before with this argument, we will panic if you want to debug so that you can get a stack trace, otherwise we'll just exit with 1. Make key list is a related function that just makes a list out of a mapped string. And that's because we have in metadata is where we define like globals, but we also define like a lot of other things, and usually a lot of these are string maps, but you might not know what like all of the values for this. So it's nice if we can just quickly make a list out of those maps, out of a map, and then, you know, just give that back and then just error that out and be like, okay, here's the ones that you can do, you know. And this one is commented out because it's a debug function. This is a print current character. It's not super literal, but it will tell us if the current character is -1, or it will print out invisible characters, so like spaces, tabs, line feed, it will print them out literally, then print out any other character, and it will also give us the line index and the index. Um, oh, well, that seems kind of silly. Line character index, maybe? Yeah. Sorry about that. The line index and line character index of that character. Um, oh, well, huh. I am just realizing how all sorts of stuff is really silly as I'm going through this. Huh. Interesting. Okay. So, yeah, so those are all the kind of the parsing helper functions. The rest of these we can get into, but those are more for when we actually get to them. Okay, so these three are helper functions. So we have collect until, look ahead, and look ahead until. As you can see, look ahead is just a alias for look ahead until, but it gives it a space. Collect until sounds like exactly what it is. It just collects the upcoming characters until it reaches the character that you specify, or rather the rune that you specify. Um, and yeah, and then it'll trim it and give it back to you. And it'll advance past all that collection. Look ahead is the same thing, except we're not collecting anything and we don't want to go anywhere. So we'll kind of pseudo look ahead until a certain point. So look ahead until you can give a specific rune, or this one will just do a space because that's the most common thing that we want to look ahead until. And we could just be like, hey, is up ahead, is there a opening parenthesis? In our language, then we know that we're probably looking at an action. Um, so that's basically what we can do. Um, yeah, we'll just keep track of our own index and basically just go through the characters and um, oh well, we are collecting something, but it's in a pseudo way where we're not actually uh, we're not see, I'm also realizing that I just put these together and I have two of these here. Yeah, nice. Um, yeah, and then we'll get it back trimmed without any new lines or any weird stuff. Could probably maybe even add like tabs. Yeah, to that. I like to do these in that order. Okay, so yeah, and those are those. And the rest are specific. So I need to give those as a prerequisite because when we're going through all this, you're gonna see tokens ahead and collect until and parser and all this stuff. So you need to know what those mean, or kind of get a look at what they do. Um, so yeah, as I said, we skip spaces, tabs, and line feeds, and then we start looking for excuse me, start looking for tokens. So this is our definition, and then we'll do name, color, and glyph, and we'll just kind of collect each of those, see if they exist in their maps. So like colors are stored as strings, glyphs are stored in their own file because there's so many of them, and they're stored as a um, what is it, a in 64 specifically, I guess. And yeah, as it says here, I just got this from SCPL because there's so many of them, you can't keep up with it. And there's probably a lot missing from here, so any contributions to that would be much appreciated. Um, anyways, so yeah, so this is that make key list thing I talked about. So like if there's a string key and string value map, we can give it that and be like, okay, here's the ones that are actually available for that thing. And so that we're not just telling you that there's an invalid icon color and you need to figure out how to fix it. We can actually just give you the colors that are available, not just for this, but for other things like this. And then there's the glyph, the inputs, the outputs. I'm not going to go super in depth with some of this stuff. Like, we just collect the inputs until we get a new line, or we collect something until we get a space. We, check that it is what we expect it to be, and then we define that. Um, so this will become more important. Like, I'll explain how these work because you can see we're just appending to inputs. What does that mean? These are like, like I was saying, like definitions aren't tokens. They determine what the icon glyph or the icon color is going to be. And whenever we're generating the plist, we just use these things because they're just single values. We just use these things when we're building the plist. So we have separate logic in the plist generator for those. So probably the most uh, complicated one, I guess, being yeah, I guess these ones that have to manually check something. And maybe like this ask for one that has to, like if they have like, I think there was one that's like stop with. No, I guess we just go ahead. Okay. Yeah. And then those are all those things. Import basically just checks if we have that library. So I'll get into actions later, obviously, but like essentially we just have like libraries that have actions that are separate from the standard actions that we make. We make those whenever we detect that you're using an action. And then this just checks if that's what you're going to do, if you're going to use that library since you're importing it. We make libraries here for that reason, which just it'll just make the map for the libraries, and then we uh, do a make call to that and provided its identifier, which I'll get into later, and that essentially just lets it make the actions so that they're defined, so that when we check for the actions in that library, they're there, and we don't just say, "What are you talking about?" Okay, so this is where we actually get into parsing stuff that we're going to make into tokens. So um, for this thing here, this is because var is a at symbol, and so token ahead, like I said, will do a space after. So if we had a variable message, we would get message if we didn't do this. So we're going back twice in the index and then advancing so that, we're not at the space. Uh, oh, yeah, we're not at the E in message. We're not at the M. We're at the at, so that when we advance, then we're at the first character in the identifier. So I guess just let me comment here to illustrate what I mean, because people don't know. So when we get var, we then go ahead, because we do one character above, like this is var. This is what defines var. Whenever we run into an at symbol, that's what we consider a variable. So then we go past m, and so what we're doing here is we're saying go back 2 and then advance, so that we, because going back 2 doesn't put us at that character. So we want to go back 2 and then advance so that we get set up to, like, okay, and now we're ready to, go character by character and collect this identifier, which will be message. Um, and then that's what we do here. So we look ahead. This is logic for like the empty variables. So if we're not going to have like equals and then the value, so we're checking if we're looking ahead until a line feed and saying, hey, if we look ahead until a line feed, do we have an equal sign? And if so, we just collect until we get a space, because then we're expecting like a set or an add to. And if not, we collect until a new line, and then we go back and then we advance so that we're at that new line. Um, and so yeah, then here we do the same kind of check again. We check if add to is ahead or if set is ahead. And if they're not, and if they are, then that's just setting the variable type. So we would collect the value all the same, but this just determines whether we're adding to a variable or setting one. Because it's like it's just going to matter what we're telling the shortcut format, like what it is. That's all that's going to matter in the end. It's not going to matter really to our collection. It's just what we output it as to the shortcuts format. So we collect value all the same. So then we go to collect value and we tell it to collect value until a new line, or until a line feed. And so we just pass it references to the value type and the value to be efficient. Excuse me. And then if the value type is variable, yeah, So this is like a bunch of really complicated logic that I'd like to simplify for typecasting and getting something as one of its properties. Not something I'm super happy with, but this is basically just so that we can separate the actual variable that we're setting as the value of this variable from what we're getting it as and we want to what type we want to coerce it as, right? Um, yeah, and then we will append to our tokens the current column. Again, I want to get rid of that. The variable type, the identifier, the value type, and the value. And then we will, if the var type is a variable, then we will actually put it in our variables map so that we can refer to it later. Because if we if we are setting it as you know, where up here the var type is var, if it's an add to, there's no reason for us to put this here, because that's not technically the new value. That's the that's a value that we're adding to this value. And while that might need to be addressed in its own way, it's just this is the only case where it makes sense right now. So that's how we collect a variable. Um, so I'll probably just go over like broader concepts with these and maybe just kind of skim through the kind of tokens that we parse. If we get a forward slash and then we get another forward slash, then we know it's a single line comment, probably. Just kind of know that this is the highest level that we can get to. So var forward slash, like, this is like we are not in any scope. We are just parsing what we're getting to go uh, in to do other things, like we just did here, where we collected a value and checked if this was that. Once we get back out and go on to the next character in our main parsing loop, uh, yeah, then we're looking at the newest character. So it would just be like if we got to the next line, we're not doing anything, we just ran into these two slashes. Then we know that it's probably a single line comment. Otherwise, we're gonna assume that it's a multi-line comment. It's probably not the best way to do it. We could probably do if asterisk, but otherwise, what are you doing if you have a forward slash? That's because it's the only context for the syntax. And then we just collect a comment. Um, I'll get into that in a moment. I want to just go through these. Repeat with each, menu, case, if. They all use grouping identifiers. This is the closure stuff I was talking about. And so whenever we get to a right brace, we will check if there's an else ahead, and if there's not, that means we need to, you know, to subtract the closure index. So we just left a closure. And here with else, this is kind of a good example of like we're using the same closure. We want the closure that's in the current index because we're probably a part of that. And then we want to just advance past that left brace. But if we are an if, a menu, repeat or repeat with each, we're starting a new grouping identifier and we're starting a new closure. So we do a plus plus. Um, yeah, and then here we just collect the value for the repeat. Here we collect the iterable type value for the repeat with each. And with the menu, we just collect the prompt, and then we start a menu under a grouping identifier. And then with the case, we go with the same grouping identifier that we have currently. Again, I want to rename that. Yeah, and then we just collect the name of the case and we append it to the the menus for this grouping identifier so that when we're building the plist later, we can do the menu format properly, but the programmer doesn't have to worry about that. If is probably one of the most complicated things that we collect, other than a variable. We make conditions, we start a grouping identifier for a closure, we started a whole closure, um, and this is like checking whether or not it's for any or empty. Um, yeah, just whether or not we have an exclamation that's the only thing that's really going to matter. We use is token because is token won't go after that. Now that I'm thinking about it, we should probably use this for var. Anyways, and then we have these variables that we declare to make a conditional. These can be nil, and that's fine. And we just collect these in their own cases. So if the next token after we collect a value is not a left brace, then we collect a conditional. We make sure it exists. And then if in that case we kind of need to assume that there's a second value, and then after that we're just checking if there's a third one because of the between syntax, and then we append a token with a condition type value that stores all three values or all two or all one with their condition. And then we have brace, that's whether or not we're starting an else part of an if statement, or whether we are ending a closure. Which probably we should stay here. I'm not making the larger like refactoring because I don't want there to be this all over the place and it's confusing. I don't mind making little changes like this though. But it's like, yeah, I wouldn't refactor the name of this to be end closure, even though it should be probably, just because I don't want to confuse anybody. And then to parse an action, what we do is we look ahead and we see if the look ahead that we get, again, this just assumes that we want to look ahead until a space, so we don't have to specify that every time. Maybe that's not a useful alias. I think that was what look ahead did initially, and then I realized that I wanted to look ahead until a specific character, like in this case. Oh, well, not in this case, but you know what I mean. So we want to look ahead until a space in this case, I guess. I think we're going to just look ahead until... anyways. We're just looking ahead and seeing if it contains an open parentheses, because that's the only time that we use an open parentheses. We don't use an open parentheses for anything else. And so you can kind of see that, like, at this point, we're getting to the end of our rope. And this is kind of the thing where we start going, like, all right, what are you doing here? Because you're not just allowed to have a literal just variable value out, so we're looking for you to do something declarative, right? Do this kind of thing. Or define this. If you're going to put a variable value, identifier, you need to be declaring it or adding to it. So because of this, we make the standard actions. I'll talk about that in a minute, like I said. And then we collect that identifier. Until then, the reason that we don't do is token is because obviously we're going to have the opening parenthesis before after the identifier. So that's why that we get the identifier, we check that it exists within the actions, and this is why it's important that up in the import thing we make we make the actions for the library, because at parsing time, we're going to tell you, just because, this is really the most appropriate time to really get all this stuff out of the way, because when we're generating a plist, we pretty much want to have all our ducks in a row. We don't want to be, checking things if we don't need to. Whenever we parse an action like we're about to do here, we do a check action, and that will actually cause a lot of checks. Excuse me. It will cause a lot of checks to happen at parsing time to check if they're valid arguments for the action and stuff like that. And actions can define their own checks, because we want to do this all during parsing. We don't want to later go and try and build the action and then find out that the arguments are invalid. Mostly, I think, just because I want to keep my error handling like pretty much in one place, and because you want to be able to reference it back to like a line and a column number and not to a token. you know so yeah, so if it's not known, then we'll say that it's not, and then if we didn't get to any of these cases, then we kind of read you the riot act and tell you you got an illegal character there that we don't know what to do with. But if it does exist, then we start to collect the arguments, which is essentially we just do what we did with the collect value, except we go for each comma separated like argument. And then once we have our arguments, we put those into check action, and then these arguments and this identifier, they get associated with the action here in the actual token. And this is very important so that we have the arguments later to build the action, but we pass the arguments here also to check the action, which I will get to in a second, because actually checking actions is kind of complicated. Defining actions is really simple, and that's kind of why checking them is complicated, because there's a lot of abstraction that's done so that actions can be defined as easily as they possibly can, without us really having to think too much about how the action's actually going to be made. But before then, I'm going to go into like how we collect values and stuff like that. So, generally we're just checking like, does the value, or does like the character that we're running into, because when we're referred here, there's a character ahead of us that's a type of value, presumably. So we're checking if the character that we have deal with is in the integer token, which just has 0 through 9 and a dot and a dash. So this character could be contained in there, and if so, we'll collect an integer. Which, collecting an integer, we're just looping while this is true, essentially. We're not collecting until we're going to stop once we stop running into a number. And so then that's the opportunity to use tokens ahead and check if we actually need to be making this an expression. And this is all very convenient, because we don't actually have to make a token here. We just have to, dereference these value and value type pointers and give them their value and value types. So, we can change our minds down here if we think it's not just an integer value and it's actually an expression value. And in that case, we just collect until we're supposed to, which is determined by this function, and then return an expression. I think we do this because I honestly don't remember. We did this for some reason. I don't remember. Anyways, we do is token string. So string token just contains a quote. So it's just if it begins with a quote, then collect a string, and that just collects until we get another quote. Which I should probably refactor a little bit because we need to be able to escape that quote, right? So another note for myself later. I kind of wanted to do this code tour because then I can watch it back and be like, oh, there's that thing I need to fix. And it's also just, good to go through this, not only so people can understand it better, but, my own internal method to my madness here. But so I can go through it and be like, oh, that doesn't make sense. Okay, so, and then the next one is an array, and it's basically the same thing. We're just checking if it's a bracket, which is what this token is, and then we're collecting an array until this. And collecting an array basically just means that we kind of make it into a JSON object, and then we just pass it to Go's JSON parser, which makes things so much easier. And then we have some weird typecasting here, where we essentially just get the array key. Do we need to be doing this? I guess we do. Yeah, we get the array key here, and then that gives us our array value. So an array is essentially just a JSON object. It just doesn't know it, and it just can't have an array inside of itself because we just literally won't. Like, you could probably put an array in there, we just won't do anything with it. And we're not going to expect you to have key value pairs too. So you'll probably run into some error with the JSON parser if you try to put a JSON object in there. And now to get to the one that can be a JSON object is a dictionary. So we are just checking if there is a left brace ahead, which this token could probably just be left brace, but yeah. We collect a dictionary, and so that just means that we wrap it, like this is part of wrapping it in an object, because we've already gotten to this character, right? And we just don't want to have to do like idx -2 advance, It's a lot better if we just go like, okay, we're missing this character, so just start this thing with that. And then we just we collect it, but we kind of forget what the logic is here with this. Oh, right. Okay, so this is like, so we're kind of detecting when we get to the end of the actual end of the object. So once we reach the end and we're not inside of an object, this is so that we can have objects inside of objects. And so like, okay, we're actually outside of the final object, and so now we can break the loop and go and parse the JSON that we've collected. So that's what that is. Yep, and then we have token ahead true, token ahead false, value type bool, true, false. Yeah. And this is another one for collecting an action. It might need to be refactored so that we're not doing the same thing over and over again, but kind of same song and dance, just checking if we have an open parenthesis ahead, making the actions if we haven't already, collecting until parenthesis to get the identifier, checking if the action exists by that identifier, collecting the arguments, checking the arguments, and then returning a value of type action with a action value which has the identifier and its arguments. And then if not, we complain. And then the default, so this is where we collect variables or globals, but we also have like the typecasting and not the typecasting. So the coercion and the getting something as one of its parts. Okay. So, yeah, so we collect this identifier, but we first want to check if we need to do that, if we need to be checking if we're going to need to split up these parts. And what we're mainly interested in, it seems like, is just getting the separating the identifier from the full identifier, because I think that we'll parse it later in the plist, which I don't know if I like. Um, yeah, and then we will check if it's a global, so we'll return it as a global. And then we pass, whenever we have a global, we pass the identifier to something called has input variables. And this basically just checks if it's a shortcut input global, because we need to then tell the format that we have input variables, which is just it's just a top level, like, excuse me, a root level key value pair that just tells the shortcut that we have uh, uh, we take an input, basically. Yeah, and then we just do the same thing with variable, except we don't have to run that thing. Um, and then if not, we're a little upset, and we tell it that we don't know the value type. We don't know what you're trying to have us collect here. You know, we collected this thing until we got to the until, but we don't know what you're talking about. Um, okay, so then we'll go into each of these like collection functions. So collect arguments. It's what you'd expect. It's gonna break if it gets to a line feed or to a negative character or to ending parenthesis. It's gonna advance. It's gonna skip. Uh, excuse me. It's gonna skip. Um, you know. Excuse me. Commas and spaces. And then we're gonna have a value type and a value. We're gonna collect that value. If we have commas ahead, we're going to collect that value until we get to a comma. If not, we're going to collect it until we get to an ending parenthesis, like depending on where we are in this kind of arguments chain, right? And then we're going to append that to the arguments, which we have set as a return type, a slice of action arguments, which I'm pretty sure is just a value and a value type. Yeah, okay. Uh, yeah, and then if we get to an ending, we want to advance, I guess, for some reason. I don't know if we want to do that. Oh, this is outside of the loop. No, that makes sense. We get to an ending when we want to advance. Okay. Okay. Yeah, so we have a comment type. This is just whether or not it's a single line or multi-line. It doesn't really matter, so we just make it an iota. We just need to have this iterable type. So this is the comment type that we're given. That just determines which comment type we're collecting. So if it's a single line, we're just collecting until it's a new line. If it's a multi-line, it's a little more complicated, and we need to trim it and advance thrice here, I suppose. No, oh, can't quit that. Trying to save my battery here. Um, okay, so we do that to collect a comment. Like I said, to collect an integer, we're just collecting and advancing as long as the character matches our integer string. So it's one of these characters. Collect string is just until we collect a quote. it will fix me. Escape quotes. Collecting an array, yeah, it's just that. We talked about that. Any others? No. Okay. Very cool. I can re-comment this out. Okay, so that is our parser. So it's maybe a little naive, but it uses a lot of tricks and little things that I've discovered in doing other parsers, doing CSS parser, JSON parser, doing parsers for doing one parser for one of my own languages before this, which is like math language. Anyways, so once we've done that, now we have all of our tokens that we've collected, and so this mainly will tell us what actions we want to make, and even if they're abstractions, so in the sense that they're maybe there's a variable token that correlates to a variable action, so most of these tokens are at the end of the day actions, and so then we make a plist. So this is in plistgen and plist.go. Plist.go, so this part may be like the most complicated. The parser is like actually fairly simple. Shortcuts is very specific about its format, and one of the things that you can do to get a little bit more familiar with it is here at that Cherri site that you can get to from the repo. I have some links here, and if you miss that, they're at the bottom here for in the credits. These go over not everything, but a good amount of what the format actually entails. Like I said, I mean, as you can see here, it's kind of, it's key, string. So string kind of declares like what the type of the value is, and then this declares what the key is. That's mainly what a plist is. It's just or a property list. It's a property list in it's a key value pair sort of thing, but in like an XML format is essentially what it is. So this kind of goes over the format in a pretty good amount of detail. This goes over it in I think a bit more exhaustive detail, because even the other one kind of refers to this one. This one goes over some very specific things about the file format. So, and that's kind of why this is so complicated, because it is very specific in some cases about how it wants you to go about doing this. So we have our long header here, which my linter is very upset about, and the HTTP link as well. So I should probably change that to an HTTPs. I just realized that's apple.com. Like, of course that's HTTPs. So yeah, then we start the dictionary, and so this is the header and the footer, right? So the footer is the ending of the dictionary and the ending of the plist. This is like XML, the document type, starts the plist and starts the dictionary. And so everything that we do from here on is contained in a dictionary. So these are all, there's like a main dictionary in the plist, but from here on out we're doing key value pairs. So there's a key tag, and then there's a value tag, and then the type of values in the tag. So so we start making the plist, and we make this map of UUIDs. And so as I was saying before, like the value is for a variable is associated with the UUID, specifically an action output is associated with UUID. I think actually variables might not be. Yeah, I think it's just action outputs. And so you can see that some of these are, so like action surfaces, like I think some people don't know what this is about. I forget. Yeah, I think that's a newer thing. So I'm just kind of leaving that empty. And you'll see here that we have some functions for doing these. And so the nice thing about this is a lot of this is abstracted. We have some types and functions and stuff. So um, this is some of the stuff I was talking about here, where it's like, you know, we defined a no input thing, and so we got the no input, and now we set what the no input behavior is, you know. But this is separate from this down here, which this is where we actually go over the tokens, which are the actions. But we have these, if we go past this, we have these outliers like input content items. These are that inputs slice that we were um, appending to, that will then go over each of those and put them in. Here's another one of those functions that abstracts making the actual tags. There's another one. And so some of these are just that. You can see for the icon here, it's like pretty simple kind of thing, where it's just this is the color, this is the glyph, you know. So we have these outliers here that just are really basic values that aren't tokens. They're just determined by things that are defined, and that's kind of why I call them meta things, because they don't really determine the content of the shortcut. They're just kind of things about the shortcut. Anyway, so yeah, so like no input is just, it's no input params. It's just a struct that's a name, which is just whatever it is, and then the actual parameters, which will just be some plist data. Plist data is a key, a data type, and a value. The data type refers to the plist data type, which this is what I was talking about with like our parser and the plist generator actually having different data types, and this is why. And it's because, uh, I mean, to keep them separate for one. So instead of saying uh, string and integer, we say text and number. We have the full on words here for dictionary and array, and boolean. So in that the types that we had in the parser were r, dict, and bool, and then we had integer and string. Here we have text, numbers, dictionary, array, and boolean. And I mainly do this because this is what they're referred to as an Xcode. Um, and so that's usually the way that I go about it. Um, so, oh, I changed from do not disturb. Whoops. Um, so yeah, so that's kind of what we base it off of, and these are going to be the tags, right? So like this would be integer tag, and then our value would be between it. And so that's kind of what these things are defining, is what is the key going to be, what's the value, and what's the type of the value, so that we can then you know, turn that into key, and then the type of the value, which let's say is the string in this case, string, or the value here, and then that's kind of what we're making out of this, but it's an abstraction of that. This is a whole other thing unto itself, and maybe I'll move this so that's not so confusing. I think that this file is not very organized very well. This could maybe go down here. Yeah, this feels more appropriate. Okay, yeah. So let's go over some of these plist functions. So the main one at the end of the day is just, like I said, taking this this data. So this is, something here that's then abstracted into a struct up here. So string plist data type any. So these correlate to this value for this function. And so we're just putting out the data type into these tags, putting the value here literally, and in the case that's a boolean, putting true or false like single tags, indicated by the fact that we have a ending slash at the end of them. And then having a key if one's given to us. This is what most of these will end up as. If they're, this is generally what you'll end up as if you're a text or a number or a boolean. But dictionaries and arrays need to be handled a little bit differently, and so that's why they have specific functions. This is an alias function so that we don't have to supply the key every time. Although I say these are key value pair files, that's not always the case, and especially in an array, you might need to just give it an array of string values, and none of them will have keys, because that doesn't work in an array. That might be the only time. I would assume anyway, because that's how it works in like a lot of programming languages, that arrays don't have keys generally, unless maybe you're in like a scripting language where you can't have keys and there's no separation between dictionaries and arrays. They just become objects based on the way that you define them. Anyways, so we have a plist array, and so this just wraps it in an array or puts it in an array closing tag and gives it a key if we give it one. A dictionary is a bit more complicated in that we don't give it a value if we get an empty plist. We give it a key just like the other ones if we're given one. But if the value isn't empty, we check what kind of value it is and use that as it. And so this function can actually recurse into itself. And we take a slice of plist data so that you can, give us just a set of plist values, so kind of like we're doing here, and this will eventually turn into a dictionary of text and dictionary values. Like these are even more parameters, so we can just chain into it and just recurse and keep doing that until we reach the end. Yeah, so some of these are not very clean. I'm looking at these now, and yeah. I think that this makes like a conditional. This somehow makes like a structure that ends up. I think that this makes a plist data structure. Yeah, because we're getting a reference to a plist data structure, and then we make the right one based on the data type. Or I think we're making a conditional parameter based on the type of the conditional parameter. Okay. We're making that from param value? Right. Okay. So the thing to know about a lot of this, jeez, that function's long, is that values, at least from my perspective, are pretty complicated. You can see here that a lot of the variable functions that or just the value functions that I scrolled by, are pretty long, and it's because the structures for them are kind of complicated, in that they nest into each other and have several different things, and this is tried to be abstracted as much as it can, but sometimes it just can't. So here we make a variable value, and what that basically means is that we're just making a value. We're making a block here, right? So if it's a string, we're making a get text standard action. which just means essentially that we're making a dictionary that has a key with an identifier and a dictionary inside of that dictionary with parameters, and those parameters specify action fields. That's all an action is. And so get text is the identifier. So by the way, make standard actions just prepends this identifier. If we were doing it for a specific app, this would be different, and that's why we have a separate make standard action function. So get text is the identifier for a text block, and number and calculate expression and so on. So here if we're doing a Boolean, we're making a number block and we're giving this parameter which determines the number value, the Boolean value which will change to 0 or 1 depending on if it's true or false. It's the same with this number one, except we're passing it directly. Yeah. And then so it's the same for a lot of these. So we're essentially just, these are how we're making values, and then we kind of have to recurse into these things to make dictionary values, which can then have string, int, array, and dict type values, but they need to be done slightly differently. And so you can kind of see there's all this logic for doing them as well. And yeah, some of this is really messy. I'm sorry. And so that's kind of what some of these are, and I can't explain some of these just because I don't quite remember how they work, because they're so I'm pretty sure this is just a specific format for the parameter for like a condition. I think that condition value and this param value are tied together, because I think this is just how we have to do it. No, I remember. So like this is a parameter for an action. Yeah. So argument value, yeah, might give you back a parameter value, or it'll give you an empty thing. Yeah, if it's optional, then it will give you nothing, and then the dictionary generator for the value, like if it gets an empty value, it's not going to make a dictionary value, so it's just going to be empty. Um, so this just makes this parameter value based on what you want to do, and this parameter value is made either to a variable plist value, which is a whole thing unto itself, because we have aggrandizements, and aggrandizements are whether or not we're coercing or getting a property variable. So that's like the get as or the coercing, so making it a content item class. So you can see we use content items, and we put in whatever they put in to coerce, so like text, number, and then we correlate that to what the actual content item would be. And so yeah, these value stuff can get pretty complicated. This one is probably like the most complicated one. So these are attachment values. So attachment values are whenever I think I can do this in like variables. Yeah. So whenever there's this, basically, whenever we inline a variable with some curly braces, essentially we look in the string and see if it has some curly braces, and if it doesn't, we just return back whatever, just a generic value for this. It doesn't really matter. If not, we need to do all this stuff to kind of keep track of like these are the variable names. I'm pretty sure this is the variable indexes. So like, what's an attachment variable? Yeah, so whenever we come across one of these, it might have, you know, a property value. So get something or give it a type. And so, we want to keep the identifier or the var name as it is here. We should probably change it to identifier maybe. But we also want to keep track of get as and coerce. So whatever we want to get it as and whatever we want to coerce it to, the type we want to coerce it to. So, oh, that's actually not the right syntax. That would be that. Yeah, and then we have different things for, whoops, what we're collecting at the time. The very number, because essentially the reason that this gets so complicated is because we when we put this in, right, for shortcuts to identify that this is intvar, so this is the number block with the value 42 that we put into a set variable block with intvar. We have to replace this with an object replacement character. And that's what this is down here, the FFFC. And then we have to have a separate thing. Where is it here? Aggrandizements. Yeah, attachments by range. And so attachments by range is like, I think, we get into it here for a minute. Yeah, where we give it like the column essentially that the variable is in after doing all this parsing and stuff. But we need to do all of this here. I think this is actually just making it, but we need to do all of this here first, because it doesn't want where the column was when it was, because like what I'm saying is, like, if we have text, what it wants is us to, so first we replace it with the object replacement character. So let's just pretend that that's what that is. And so we need to keep track of what index these variables are at, so that when we do that, we can go back through here. And so, let's say there's like another object replacement character here, so that we can parse through here and then find an object replacement character and then go like, oh, so this is like, variable 0. This over here is variable 1. Oh, then I'll set that the actual position for that variable is at this column, because that's the way that Shortcuts wants to see it, essentially. And I'm sure that in Shortcuts this works much better, but when you're having somebody put it in a string like this, not exactly. I don't know, maybe it works the same way, but it took me a second to figure that out. How to get that working in a way that would work consistently and work just fine. So that's kind of why this function is as complicated as it is, because that's what it does. It does some complicated stuff here. So yeah. So then yeah. So that's kind of values and stuff with like plist generation. I guess we can like go through here and then eventually get to actions and how we actually put them together and check them, because that's kind of a whole topic on its own. Yeah, so we go through each token in the plist generator, and here we're making a variable, we're setting the parameters, we're making a variable value, which is that whole thing where we were going through like, is this a dictionary? Okay, so let's actually generate now all of the uh, key value pair tags for that dictionary. That's essentially what this does. Uh, you know, whether it's a dictionary or it's a string or it's a number or whatever it happens to be. Um, Let me get some water. Okay, so the next thing is that, so this is where we make variable plist value. So I think that we do this just because, like, we make a variable value, but it also involves aggrandizements and checking if the variables exist or if it's a global or whatever it happens to be. And that's why we have a function for that. And then we do an input value, which is kind of a thing unto itself, and it's essentially just inputting the output of an action. That's mainly what we use it for. I think maybe this format would extend to other things, but that's the only thing I've really seen it do. It's just you have to give it an output name, an output like where the UUID of the action that it's coming from. It has a we have a specific type for it. Type like what type of variable is maybe coming in or out or whatever. Because we might also give this like a variables UUID, like those UUIDs I told you we're keeping track of. That's what the variable input is. It's like we're just it's just an alias function for this, but we're getting the UUID of the variable, so that when we input it into this input value, because input values are mainly like places you're only allowed to put a variable in. Like maybe you've seen this if you're going around shortcuts and like a good example is like an if conditional. Like the first operand of that conditional must be a variable, so that's the place where you'd put that. And this is generally like for that, and so we'll also do that with like globals and variables. Obviously, that doesn't apply to globals, but that will apply to variables because they'll have a UUID. Because they essentially have an action output. Right, and then if it's a variable, we'll make a standard action set variable with those parameters. If it's not, we'll do append. And if it's an array, like I said, what we'll do essentially is we will uh, do a bunch of append variables. Like this is separate, right? This is adding to an existing value. An array will make these variable values like we do up here. Um, but in this case, we're taking the UUID that like because essentially make variable value is making a block that we can kind of put into a variable. So in this case, we're making a block, we're giving it this UUID, and this is how we're going to identify it. We're then like putting that into an append variable, which we already uh, um, set this variable. We just didn't make any parameters for it, so we essentially just give an empty like set variable, and so we started the variable out and we declared it, and then here we're just adding to it. We just keep adding each value in the array essentially. And so here we can add a dictionary, a number, or some text. I think we could technically add a boolean, but I don't know if it would really matter because you can't really select stuff out of the array unless you do like get list item or something, which I don't know if that would apply to an array. I didn't really deal with arrays in my time, like doing shortcuts more actively. Um, yeah, I don't know. Yeah, and then an action just takes its token value and makes a comment action. And then we will get to this. This, yeah, just like gets the identifier from the action value of the token and sets that as the current action, and then we send the args to calling the action, and provide it some empty stuff for the output name and the identifier for the action. Just because we're here, I'm pretty sure we're just calling this. Yeah, we're not. Basically, these are if we were to set the value of a variable to the output of this action, but here we're just calling the action, so we don't have to give it anything to like link it to anything, basically. Yeah, and then a repeat. Yeah, we're just making blocks that basically just signify what control flow mode it is. And like generally like a 0 means that we're starting. So like here you see like since it's not an end diff, which should probably be end closure, like I said, um, then we're doing 0. If it's an else, it's 1. But a repeat doesn't have an else, so when we have an end diff, it's 2. So it kind of keeps it consistent. And that just tells it like yeah what mode it's in, so it knows which one it should render. But it's still a repeat count action. So like with a conditional, it's going to be the same thing. It's still a conditional action, but depending on what control flow mode it's in, that's what it's going to expect different parameters basically. And then we have the grouping identifier that we were talking about. So these are the UIDs that we make during parsing, and we make those during parsing for this reason, so that we already have identifiers to group these things together. Yep, and then we have a parameter value for the count. I don't know if we need to be doing that, but I don't know. This is something I haven't addressed yet. Specifically because that seems kind of redundant. Yeah, and then it'll be kind of the same for repeat with each. Menu's a bit different, but not really. Yeah, it's just doing like the prompt, and then we get the menu item, so we take that identifier for the menus, which this will basically just hold that grouping UID for this menu that we put into the tokens identifier, and then that'll just give us the items. And then as you can see here, we have a WF menu items that we have to put for the starting block of the menu, and that's why we're keeping track of these items that we're adding to this menu that we started, so that we can then put them here, but we kept track of them, and the person programming didn't have to do that. So, which might have to change if you're like putting variables in as the thing, or like inlining them. I don't know. But yeah. Because I don't know if the actual case names are going to matter. And I might just leave them empty at some point. Because I saw some other people do that with their languages. Like, I think it doesn't technically matter what the title is. And shortcuts will kind of fill that in. It just matters that the items are there and that they have the same grouping identifier, I think. So that might change. But yeah, I would just make these actions and then conditionals. So a lot of this is just taking what we have from the token and just applying it to like parameters and such. Yeah, this one we kind of make on like a switch because a lot of it is the same. It's only in the case of the if that we actually add the condition and the values. Yeah, and then we're appending these. Basically, these are a big slice of strings. Essentially, because that's what this will put out eventually. So, like, if you follow standard action, the make action to plist dictionary, this is just going to return a string. So, at the end of the day, this is a giant string builder, essentially. We're just building a string that's eventually going to be our property list file. And then we have the rest of these, and yeah, so yeah, and then this is the thing at the end where we print all the UIDs for debugging. Um, okay, so let's get into actions. So I was saying earlier, so we need to start with parsing. Like these are a thing to like go on their own. Um, actions. So so yeah, so we make the standard actions. Why do we do that? Because we have a file like just like we have for plist. So we have plist gen and then we have plist. We have another thing like that where we have action standard where all the actual actions are defined, and then we have a whole thing of like types and helper functions and stuff like that. Okay, so this should I think be like the final thing to get through in this whole thing. So in the parser we start doing this, so we make the standard actions and it essentially just tells us to make all the actions, which actions are just a map with a string and an action definition, and an action definition just contains definitions of the parameters, um, and then and has an optional like identifier, which is to just like specify an additional um, a custom identifier for that action. Sorry, I kind of lapsed there for a second. Yeah, and then we have like stuff for like making and checking and doing all this stuff. We're essentially just giving what the actual syntax for the action should be. So like this is like add seconds, but the identifier for the action is actually adjust date, and then we're like defining what the parameters should be, and this is also kind of defining what like the argument should be. This was originally like argument definition, but that seemed kind of confusing because these are really defining the parameters, just they're also used for the arguments. Um, and these are the actual arguments that we receive, but these are also used to define the parameters. Um, so yeah, so and then we can optionally give a like a make function or a check function. So check is run during parsing, and then make is run during plist generation. So make actually gives the plist data, but this is optional because from these parameter definitions we can kind of garner how these should be made. So you can kind of see here that yeah, argument value we have args and 0. Well, we can just add a key to this. Like this is something that needs to be done with more actions, so I can use this as an example. And we can garner, we can pass args. We can get that somewhere else, and wherever we're making actions, and then we can get this from the index of the parameter, so we don't even need to have this. But if we need to do something here, like add seconds does, where it's adjust date, because a lot of these functions need to do a similar functions. A lot of these actions here, excuse me, need to do the same thing. then we'll have a make function to do that. And so so this is like where the actions are defined, and this is kind of like definitions that will help us garner like what to do when we get this action. And then when we collect the arguments and we collect each value, so we kind of went over that, we have these values, and so when we go to check the action, and we check that the length of the parameters is greater than 0, so we actually have some parameters to check, because sometimes we don't have parameters at all. Um, you know, when we're talking about actions, we actually have some of these in here. Where is it? Like, yeah, that they can be as short as this. Get current song is the identifier of this action, and so we're just specifying that camel case is going to be accepted for this action. But it doesn't actually have any parameters, and this is also the identifier. So we can just make this lowercase and use that as the action identifier. So here it's like we actually need to make sure that there are parameters, and then, this is, like I said, at parsing time, so we're checking if there's a check function, and if there is, then we pass it the arguments, because check is a param check, which is just a function that takes a slice of action arguments. And so we do enough arguments, which essentially we just pass a reference to the arguments, and we're just checking if there's enough arguments for the parameters, and we're also checking here if the value is optional, and we're also using the what am I saying? We're also using the default value for an action argument. We should probably go over that in a second. I'm sorry. To see if that value is equal to the default argument. Let's go over there and look at that. So so we have an argument that's a value type, but we have a parameter definition. So parameters can have a default value, which can be an action argument. So just like, hey, by default, the default value has this value type and this value. So if you, like I was saying, we can check that and go like, okay, you gave us the exact same thing. That's kind of stupid. It's kind of pointless. You don't need to give us the same value. We don't even need to write this. We can make a smaller shortcut file if you just omit this value. So that's what that is for. The name is the name of the field, and so this is basically just for having a name for documentation, and also like if we run into an error with this parameter, we have a name to call it. So like, hey, hash type. You didn't give us the right hash type for the hash action, rather than just parameter 0 or argument 0 or whatever. And then we have the valid type, and so this is the type to compare it to. This is what it should be. We also just use this for if we're just going with making the arguments parameters automatically out of the arguments. We use this to tell it what it should be. And then we have whether or not it should be optional, or whether or not there should be a max number of arguments. So we can essentially just define one parameter, which will correlate to the arguments, and just say that there's no max. So like the URL action, for example, will do this. And it will say that I have no max arguments, so we can have as many variables, we can have as many URL arguments as we want, just like we can in shortcuts. Right, so yeah, then we take that. It's telling me to do something here. That's simpler. So we make, if it's not optional and the default value isn't equal to nothing, trying to just assess like if this is necessary, because I'm like, okay, so it is optional if it's else. So we don't need to give it a default value. Sorry, I don't mean to be doing refactoring while I'm talking about this. Yeah, so here we're checking like if there's not a max number of arguments, then we don't need to be checking it. As long as we have like the first, argument, we don't need to be checking default values or optionals. Like we need one argument basically if this is going on. And so feels like this is doing something else. So this is more of an arc check, I think. I think that see, so this function was made when we were just checking if we had like the minimum number of arguments, and I think now this is more just like checking if we have the required arguments, because they'll say if yeah. So we don't have this can just be if it's not optional. And the value is equal to nil, then we can go, hey, you're missing this required argument. Okay. Yeah. Okay. And then we'll do check types. So this will just check the valid type against the type of the argument. And this is particularly complicated because we have to evaluate the variable. We have to kind of get to the end of, because a variable, like a variable can store another variable and that can store another variable. So we need to kind of, recurse down until we get there. So, for each of these, we do a type check. This is where we check if the default value is equal, which is maybe a little bit silly to be doing here, because it seems like we're doing a multi-purpose thing there. But I don't know. Yeah, and then this is where we do the actual type check. So we have to get like the real variable value, which is just like, recursing on ourselves and evaluating the actual value and making sure that the value that we end up with at the end of like a variable chain is the type that we expect, or the valid type. You can kind of get away with this in a stupid kind of way, literally just by what is it, like literally just by having the valid type be a variable, because that means that like, yeah, this can kind of technically be whatever like it really needs to be, because then I guess kind of at that point it doesn't really matter, because like shortcuts isn't super strict about types, but it is a little bit. And then also, if the argument value type ends up being an action, we just kind of return, because it's like, well, we haven't really gotten to defining what an action is supposed to output, and we'll need to do that at some point, by probably just taking the identifier and then getting the output type that's defined. There's probably just a little bit of work to be done there on that, and then it should be good to start defining them and then doing something here as long as they are actually defined. I think part of me just wasn't sure quite what to do, because it seems like it might be more complicated than that. Check identify. Okay, yeah, so that gets more into other stuff. Yeah, okay. So that's the parser stuff for now. And then we get into the actual property list. And so then we call the action. And so calling the action, this is where we can do stuff automatically, or stuff can actually be here for us to do. So like we can just call understand making the actual action to the action itself, to the definition. So this is kind of some logic for like app identifiers. So this is like if you have like a non-standard action and you need to specify, like com.company.app sort of thing. Um, yeah, and then this is yeah. So checking if we have an identifier, and if not, like taking the key, which is the current action, and putting it lowercase, and then putting that as the identifier. Um, because if we don't give an identifier, we've basically said that it's okay to do that. Um, right, and then if the make thing isn't there, or is there, then we pass the arguments to that make thing, and then the actual action definition makes the action. If not, we check if we have any parameters and then actually make the action ourselves, which is just making parameter values. And that's just dependent on whether or not it's a variable or an argument. Yeah, and then we do something called check identify, and this is where we get past those output names and action UIDs, and this is basically just like whether or not we basically whether or not we are, I think, like linking this action to a value essentially, um, to like a variable value. I'm pretty sure. So yeah, so this is like whether or not to put the UID and output name that we've been given. So if we were given one, then we need to do that. And maybe we don't need to have this in its own function. I think maybe at the time it just felt cleaner. Here we are, to do it that way. And then we actually append the actual action that we make here to shortcut actions, which just outputs a string, which is just the action identifier that we've been given, and the parameters, which we put into the dictionary, which just recurses on all those dictionaries, and then eventually returns a dictionary string, which can then go into the actions, which can then go into the actual plist. So, or the array of actions in the plist. Like, there's a lot of abstraction here. It just keeps going. So yeah, that's about what we do. Argument values kind of had to do with what we were kind of explaining before. I think the only difference being just that, like, yeah, we have to make dictionaries, make dictionary values, and those get into very like complicated data types. But I think those you can kind of garner for yourself. I don't really see any to like just explain them. The only thing I'll say is like for dictionary values, we do have these like string type, int type, array type. These are specific types that we end up with commonly, and so like it was just kind of suggested by like the linter that I use to put these into common constants. That wasn't what I meant though. What I meant was dictionary data types, which I think just start at the top here. So yeah, dictionary data types. So whenever we make a dictionary, we have these item type. Because in dictionaries, data types will actually correlate to numbers, like they do here. So this is, yeah, when we're making a dictionary value. So I was almost there. Yeah, we'll just have to give an item type, um, which will make its way here. WF item type, which will just be a number. So I wanted to make sure I explained what this type of data was. So yeah, I don't think that I really have anything else to explain. That's pretty much how she goes. So yeah, that is my